Problem number 30, change of variables. We need to evaluate the integral over region D of x, y, dA, where x and y, the bounds on x and y for D are given right here. Let's just draw those really quick. So y is equal to x, y is equal to 3x. And then xy is equal to 1, xy is equal to 3. Those are hyperbolas. So the region looks something like this. Okay, we are already told what transformation to use here. We're told use x equal to u over v, y is equal to v. What are things we need to do? We need to find the Jacobian here. So the Jacobian, transformation, is going to be the partial derivative of x with respect to u is 1 over v. Partial derivative of x with respect to v is negative u over v squared. The partial derivative y with respect to u is 0. Partial derivative y with respect to v is 1. So the Jacobian here is 1 over v times 1 is 1 over v minus 0. Okay, what about bounds? What about bounds? We need to change bounds to be in terms of u and v. So one bound is going to be take y is equal to x and substitute in v is equal to u over v, which is equivalent to u is equal to v squared. For y is equal to 3 times x, this is going to be v is equal to 3 times u over v, which is u is equal to 3u is equal to v squared, where u is equal to 1/3 v squared. Okay, 2 down, 2 to go. X times y is equal to 1. Well, x is u over v, y is v. This is equal to 1, but those v's cancel, and we just have u is equal to 1. And then finally, xy is equal to 3, so this is u over v times v is equal to 3, u is equal to 3. So it looks like our bounds here are going to be u is equal to v squared, u is equal to 1/3 v squared. I've written everything in terms of u is equal to things. So we can see here bounds on u are from 1 to 3. But really, we should rewrite these to be v is equal to things. So this one would become v is equal to the square root of u. And this one would become v is equal to the square root of 3u. We don't have to worry about plus minus on our square roots because everything, we're working in the first quadrant here in the xy plane, and then correspondingly u and v will both be positive. Okay, so I think we're ready to write down everything here. So we have the integral, u runs from 1 to 3, v runs from square root u to square root 3u, x times y. X times y is u over v times v, and that's just u. And then throw in the factor of the Jacobian. Everything in sight is positive, so we don't need absolute value here. 1 over v dv du. Okay, so I'm just going to leave this as a setup here and not evaluate this. This should be not too bad of an integral to evaluate here.